Hi grade 11s, this is JP, and today I'm going to take you through the solutions to exercise 4, the sum of arithmetic sequences. Right, let's hit it. So question 1, you need to do A and C. So in question A, 5, 8, so it's 5 plus 8 plus 11 plus and 20 terms. Alright, so I think it's always useful to just write down quickly, what do you know so far? So we know A is equal to 5, we know the difference is equal to 3, we know N is equal to 20, right, because it's up to 20 terms. In other words, we want to find out what the sum of the first 20 terms will be equal to. So we use any of those two formulae, it doesn't matter. So Sn is equal to n over 2, 2a plus by n minus 1d, you can use here. So the sum of the first 20 terms is going to equal to 20 divided by 2, 2 times by a, and a in this case is equal to 5, plus by n minus 1, and n in this case again is going to be 20, so it's 20 minus 1. And then the difference, which is going to be equal to, the difference is equal to 3. So times by 3. Right. So the sum of the first 20 terms is going to be 10. 20 divided by 2 is 10, right? 2 times by 5 is 10. And then 20 minus 1 times by 3 is going to equal to, what's that, 57. And so what we've got is we've got the sum of the first 20 terms is 10 times by 67. So that is equal to 670. Okay. If you were hell-bent on using the other formula, so n over 2, a plus by l, you just first had to work out the value of the last term, right? In other words, you first had to work out the general term, right? And then you work out what T20 is, T20 was, and just substitute that into there, right? Okay, but that's not a big deal. You can still do that. Okay, question B. Here we've got minus 14, and then we're going to add minus 9, and then the next term is minus 4. I like separating it like that. Okay, so what do we know about this question? Well, we know that a is equal to minus 14. We know that the difference, you need to add 5 to every single term to get the next term, so that's 5. Okay, and we need to find the sum of 100 terms. In other words, we need to work out what S of 100 is. We don't have the value of the last term, so I won't use that formula again. I would just use my default n over 2, 2a plus by n minus 1d. Right, so the sum of the first how many terms? So it's the sum of the first 100 terms is equal to 100 divided by 2. And then 2a, and a in this case is going to equal to minus 14, plus by n minus 1, and again, how many terms are there? There is equal to 100, so it's 100 minus 1, and then the difference, which is equal to 5. So therefore, the sum of the first 100 terms is equal to 50, that's minus 28, plus by, and 100 minus 1 times by 5 is equal to, what is that, 495? Oh, I don't know, hope so. And so the sum of the first 100 terms is equal to 23350, okay, 23,350. Right. Alright, so let's look at question 2a. So I give you a sigma. Sigma means sum, yes. So this is the sum of that general term there, 3k plus 2. That makes it, you can see it's an arithmetic sequence in that form, it's linear. And I want to know what the sum is. Okay, so what's the first thing we're going to do? We're going to work out the sum of the first 3 terms, or actually the values of the first 3 terms, right? And okay, let's get it. Okay, so in other words, the first one will be 3 times my, and you substitute the bottom counter into it, right? 3 times by 1 plus by 2. Right, good. Hopefully that makes sense. And then the next one is going to be, well, 3 times by what is the next integer? So here we substitute 1 into, okay? What's the next one we're going to do? We're going to substitute 2, the bottom counter, and then plus 1, right? The rest still stays exactly how it is. And for term 3, the next one again, in this case it is just 3 times by 3 plus by 2, right? And so it keeps on going until we're going to substitute 3 times 100 plus by 2, right? Good. So in other words, it's going to be 5, right? 3 plus by 2 is 5, and then 6 plus by 2 is equal to 8, and then we've got, so it's 9 plus by 2 is equal to 11, and dot 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 dot, and then 300 plus by 2 is equal to 302. Okay, let's just make those green for all those of you that's a bit OCD. So, right, okay, so we've got an arithmetic sequence there. We've got the first 3 terms. Why is this important? Because now we know a is equal to 5, the difference is equal to 3, and I know how many terms there are. Remember, it's the top counter minus the bottom counter plus 1. So it's 100 minus 1 plus by 1. In this case, it's 100. Right, if the bottom counter starts at 1, remember, then it will just be the top counter. Good, so that's not too bad. And we want, in other words, to know what the sum of the first 100 terms will be. Right, because we have the value of the last term here, we can use either formula, it doesn't matter. Power's yours. Use it wisely. So n over 2, 2a plus by n minus 1d. Alright, so it's the sum of the first 100 terms is equal to 100 divided by 2, and then it is 2a. What is the value of a? A is equal to 5, right? Good, that's why this is quite nice. And then we've got plus by n minus 1, and what is n in this case? It's 100. And then we multiply that with the difference which is equal to 3. Alright, so in other words, the sum of the first 100 terms is going to equal to, so it's 50, that's 10 plus by 100 minus 1 times by 3 is equal to 297, and sum of the first 100 terms then is going to equal to 50 times by 397, so sum of the first 100 terms is equal to 50 times by 397, so that's 15,350. Okay, let's look at question 2b, or not 2b. So we're going to work out the first 3 terms, the values of the first 3 terms again. Dot, 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 and then we also know, well, okay, and that's going to be the last term, right? Not term 50, but and actually that's how many terms are there going to be in the sequence? 50 minus 2 plus by 1 is equal to 49. So there's going to be 49 terms in there. Okay, so how do I do this again? I'm going to say, well, it is 5 minus 2m, 5 minus 2m, 5 minus 2m, 5 minus 2m, right? Okay, and what we're going to do, we're going to say 5 minus 2, and we're going to start with the bottom counter, then we're going to go 5 minus 2, 1 up from the bottom counter, 5 minus 2, 1 up again from the bottom counter, and then 5 minus 2, and until we reach the top counter. So what's the bottom counter? The bottom counter, in this case, starts at 2. We're going to substitute 2 into there. So no, it's 5, so it's 2 into there, and then 3, and then 4, and then 5, and 6, and 7, and 8. Get the idea, until you get to 50. Alright, so let's go for it. So it's 5 times by 2 minus 2 is 5 minus 4, so which is equal to 1. And then the next one, we've got 5 minus 2 times by 3, 5 minus 6, which is equal to minus 1. And then the next one, 5 minus 8, which is equal to negative 3. And so it goes on. And until we get 5 minus 100, which is equal to minus 95. Alright, so that's what we've got so far. So what do we have? We have a lot. We've got a is equal to 1. We've got d is equal to what? D is equal to minus 2, right? You minus 2 to every single term. If you're not sure how to do that, again, term 2 minus term 1, that's the same as term 3 minus term 2. Alright, and what else? We've got n. How many terms are there again? 50 top counter minus bottom counter plus 1. So n is going to equal to 48 plus 1 is 49. And we need to find out, in other words, the sum of the first 49 terms. Let's hit it. So therefore, says the sum Sn is equal to n over 2, 2a plus by n minus 1d. So it's the sum of the first 49 terms is going to equal to 49 over 2, and then 2a plus by n minus 1, and then the difference. So in other words, a in this case is equal to 1, n is equal to 49, and the difference, which is equal to minus 2. Alright, so it's the sum of the first 49 terms is then 49 divided by 2, 2 plus by 48 times by minus 2. It's the sum of the first 49 terms, and you can just put this all in your calculator. Then you get minus 2303, minus 2303. Okay, let's look at question 3a and 3b. So how many terms are there in the series negative 3 plus 1 plus 5? What am I doing? So plus 5 plus, I think, until we get plus 313. Okay, so what do we have so far? So now I didn't give you to in sigma form, sum, remember. So then a is equal to negative 3, d is equal to what is in this case? What do I need to add to negative 3 to get to 1? You need to add 4, right? And from 1 plus 4 is 5. And then, okay, and then we need to find n. Do we know what n is? No, but we know the value of a term. So the first thing, if we have the value of a term, we want to know n. Remember, what do I need to do first? We need to find the general term. Okay, so that will be our objective there. Right, and then of course we're going to find Sn. Whatever n is, we're going to find the sum of all those terms. Okay, so this is the longer way of doing it. So let's first work out the general term here. The general term would be Tn is equal to a plus by n minus 1d. So Tn is equal to negative 3 plus by n minus 1, and the difference is equal to 4. So Tn is equal to negative 3 plus by 4n minus 4. So Tn is equal to 4n minus 7. Alright? And then I have the value of the term. I know the value of the term. Term then is 313. So 313 is equal to 4n minus 7. So 4n then is going to equal to add 7 on both sides. So that's equal to 320. And then n is going to equal to 80. I think it's 80. Okay, so that is going to, in other words, this is the 80th term. There is, in other words, 80 terms in this sequence. So in other words, now we've got this baby. We know what n is, that's 80. So in other words, we're going to find the sum of 80 terms. Good. Let's go for it. So in other words, we've got Sn is equal to n over 2, 2a plus by n minus 1d, right? So it's the sum of 80 terms is equal to, and then again it is n, which is 80 over 2, 2 times by a, n minus 1 times by the difference. A is again negative 3, there's 80 terms in this sequence, and then the difference is equal to 4. So let's go for it. So sum of the first 80 terms, oh my goodness. So sum of the first 80 terms, oh, It's not getting any better. Minus 6 plus by, what's 18 minus 1 times by 4? That is equal to 316. And so the sum of the first 80 terms, yes, got it. So 40 and minus 6 plus by 316 is equal to 310. So sum of the first 80 terms is then 40 times by, so that becomes 12,400. Okay, you could have also used the other formula, that one that's not on the formula sheet. So I'm just going to do it here on the I'm going to do it here on the bottom. So in other words, if I use the formula Sn is equal to n over 2a plus by l. In this case, I have the value of the first term, so it's actually quite easy then. We still need to know that this is the 80th term. So in other words, we still need to do this whole step here, okay, to find n. So in other words, the sum of the first 80 terms is equal to then, and it's 80 divided by 2, 80 divided by 2. The first term, a is minus 3, and the last term's value is 313. So it just makes this part a bit easier, right? So it's the sum of the first 80 terms is then 40 times by 310, and that is then also equal to 12,400. Right, so how many terms are there in the sequence? Well, we know there's 80 terms in the sequence, and what is the sum of, so this is in other words the answer of 3a. What is the sum of the sequence? The sum of my sequence is equal to 12,400. Okay, in 5b, we need to find the sum of these terms in the sequence. The first term has got a value of 21, so a is equal to 21. The difference here is 2, right? You add 2 to every single term. We know the value of the last term in this case is 255. Do we have the value of the last term? No, not yet. So we need to know, so if Tn is equal to 255, we need to know what n is equal to. All right. In other words, we want to know which term has got a value of 255. That's important. We need to know how many terms are there in the sequence. All right. So let's go for it. So the first thing we need to find which term is equal to has got a certain value, we need the general term, right? So the general term. So therefore, Tn is equal to a plus by n minus 1d. So Tn is equal to a, which is 21, plus by n minus 1, and the difference is equal to 2. So Tn is equal to 21 plus by 2n minus 2. So Tn is equal to 2n plus by 19. All right? So in other words, what we're going to do now is we know the value of the term. So 255 is then equal to 2n plus by 19. So 2n then is equal to 255 minus 19, and that is equal to 236. 236. So then, and then that divided by 2 is equal to 118. All right. So in other words, what we saw now is the term 118 has got a value of 255. So this sequence climbs very slowly, just 2 at a time. Every single one's just increasing by 2. Okay, so now we can use either formula. It doesn't matter which one. Sn is equal to n over 2, 2a plus by n minus 1d. So the sum of how many terms? The sum of 118 terms, in other words, is going to equal to 118 divided by 2. So it's 2a plus by n minus 1. And then the difference. And what is n equal to, a first of all is equal to 21. N is equal to 118. And the difference is equal to 2, so it's the sum of the first 118 terms, and that is equal to 59 times by, what's that, 42 plus by 117 times by 2 is 234. I hope you're putting me on a lot of bridge, you guys. And then what is that equal to? So it's 59 times by, what's that, 276, and 59 times by 276 is equal to 16,284. Right. Okay, question 7a. How many terms of the arithmetic sequence? 3, 11, 19. So it's 3, 11, 19, dot, 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 will give me a sum, so we don't know what n is, of 1,580. Right, good. So we want to know what n is. We have a, which is equal to 3, and we have a difference, which is equal to 8. Right, 3 plus 8 is 11, 11 plus 8 is equal to 19. So in other words, let's go for it. We've got enough to get started. So Sn is equal to n over 2, 2a plus by n minus 1d. So we know what the sum is. What is the sum equal to? The sum is equal to 1,580, right? So 1,580 behave is equal to n over 2. We don't know what n is. We're going to find out what that is. A, which is equal to 3, and then plus by n minus 1. Again, we don't know what n is. And the difference which is equal to 8. Right, so let's go for it. So it's 1580 is equal to n over 2. So that's 6 plus by 8n minus 8, right? Expand. So in other words, n over 2, so that's 8n, right? And 6 minus 8 is minus 2. Now listen, you're always going to get a quadratic, of course, here. So don't freak out. Just go through the motions. 1580 times by 2 is going to equal to 3,160, right? Is equal to n, 8n minus 2. You follow what I did? Multiply by 2 on both sides. Right, and then expand that. 8n squared minus 2n is equal to 3,160. Subtract on both sides to get into the right order. 8n squared minus 2n minus 3,160 is equal to 0. And then if you're going to solve that using the quadratic formula, you're going to get n is equal to 20, or n is equal to minus 19.75. 19.75, of course, is totally crazy. I mean, that doesn't make any sense. It must be n is equal to 20. That means the sum of the first of 20 terms of that sequence that starts at 3 with a common difference of 8 will have a sum of 1,580. Okay, and then the last question, question 8a, to determine m in each of the following. So, okay, so the first thing we're going to do, sigma means, come louder, sigma means, yes, well done, sum. Don't talk to me. So, sigma means sum. So what we're going to do is we're going to first work out the values of those first 3 terms, right? And then, good, let's go for it. So in other words, it is 7k plus by 5, put this in brackets, and then plus by 7k plus by 5. Just write those general terms down. You don't need to show all these steps. Of course, I just want to show you guys, because I'm alone, and I'm social distancing, and I'm missing you. Alright, so that's just why I'm doing that. So plus by 5, plus by 7 times by, oh goodness, k plus by 5, and then da da da. Okay, so we're going to start with the bottom counter. What's the bottom counter there? K is equal to 1. So it's 1, the next integer is 2, the next integer is 3. We keep on going until we've got m, right? But we need to find m. Okay, so the value of the first term, 7 plus by 5 is equal to 12. And then 7 times by 2 is 14. 14 plus by 5 is equal to 19. And then we've got 7 times by 3 is 21. And 21 plus by 5 is equal to 26, hopefully. And plus, plus, plus. And that looks like a common difference of 7. You can actually just check there. The common difference would be 7, so if it's in the right format, but you'll pick up these tricks. Okay, so what do we have so far? We've got a is equal to 12, we've got the common difference, which is 7. N, do we know n? No, we don't know n, that's what we want. Alright, and do we have the sum? Yes, we have the sum. The sum is equal to 1287. Alright, so therefore Sn is equal to n over 2, 2a plus by n minus 1, and the common difference, the common first difference, d. So we know what the sum is equal to. Sum is equal to 1287, and that then is equal to n we're working out, 2a, a is in this case is equal to 12, right? Plus by n minus 1, we don't know what n is, and then the difference, which is equal to 7. Okay, let's hit it. So therefore 1287 is equal to n over 2, 24 plus by 7n minus 7. So, and here we've got n over 2, so it's 24 minus 7 is equal to, yes, 17 plus by 7n is equal to 1287. Okay, multiply on both sides, then you get 2574, I think, and then 17 plus by 7n. Right, and then what we've got is we've got 17n plus by 7n square is equal to 2574. What now? So therefore 7n squared plus by 17n minus 2574 is equal to 0. Okay, so we're going to get two solutions. N is equal to 18 or minus 143 over 7. That other one, of course, makes no sense, so that's not applicable, not valid. So therefore n is equal to 18. That means the sum of 18 terms of that particular sequence will give me a sum of 1287. Okay, now listen, I'm going to quickly just put the answers of the rest of the exercise up here. You can just, if you battled with some of these questions, do some of the other questions, and then just mark your work. Right, so there's exercise 4 solutions. There's 1A, there's 1A, there's 1B. Question 1C is 23350. There's question 2A, there's question 2B, there's question 2C. Right, so maybe just if you're battling with some of them, just try these. So question 3A, there's 80 terms, and then you can find the sum. And question 4A, there's 22 terms in the sequence, and then you can find the sum. Question 5, you find the sum of that, sum of the first 12 terms. You first work out n is 12, and you find that, remember. And then 5B, there's 118 terms in the sequence, and then you find the sum. There's 5C. 5C continues here on the bottom. 5C is sum of 18 terms is minus 837. There's question 6, is that one with the 500 first odd numbers. So there we go. You can remember, just look at that previous video. That's quite cool. Question 7A is, there we go. We did this one. There's question 7B that you didn't. No, we did this one as well. Did we? I don't know. And then question C, there's question 7C. Okay. And then the rest, there's question 8. There's just pause. Question 8B, 8C. There's question 9. Don't worry too much about question 9 yet. That's quite high order. We'll get there. This is grade 12 content, so don't be calm. Be calm. Stay calm. Wash your hands. And question 10. There's question 11 and 12 and 13 and lastly 14. Okay. Thanks, grade 11s.